Hey all, Federico here, and welcome to the third and I hope final part of our tutorials on MC Granular Synthesizer. So in this final video we are going to put some parameters to our synthesizer. We're going to see how we can randomize some things and how we can control different aspects of the synthesizer. So actually it's not gonna be a lot of things, so let's dive into it right away. First, let's hear actually what's the current state of the synthesizer. So if I raise a bit the volume and diminish a bit this interval for the metro, now it will go crazy. Every 1 millisecond it will create a new voice. The file is Cherokee, one of these built-in audio from Max, Cherokee. So sounds like that, which is funny, but it's not really there yet. So as the synthesizer is selecting one random piece of audio from the whole audio file at a random place. So if we go here inside the subpatcher grains params, here we get that we are selecting a random number between 0 or 0.001 and the total length of the audio file. So it's just taking one random number between the beginning and the end of the buffer. And then we are summing a duration of 50 milliseconds to that to read. So we're going to read 50 milliseconds of this audio file, and we are playing those 50 milliseconds on a fixed amount of time, which we can choose from this sender here, which is also 50 milliseconds. So we are reading the grains at their original pitch, because we are reading 50 milliseconds in 50 milliseconds, so they're going to sound at their original pitch, and we are reading a random portion of this audio file, so the grains are taken randomly on the whole duration of the buffer. So what we want to do now is to actually not get a random duration in the buffer, but to actually select it manually. So let's say we want to start from here, or maybe we could just play the whole buffer and granularize it as long as we move through it. So this will be something nice to have. So we need a starting point in milliseconds. Then we would like to have probably a pitch of the grain, because at the moment we are playing the grains as we said at their original pitch, but we could choose to play them at double speed or slower, so we could have a control for the pitch. And then the grain duration, which means basically this number here, how long each grain is going to be in time, so the physical time to play one single grain, how long is this going to be. Okay, cool, so this will be our three parameters for the moment. And let's start with the starting point in milliseconds. So let's create a way to read a precise point in the buffer that we choose. And in order to do that, we can do like this. We could use the select mode of the waveform object, but I would like not to mess too much around with the waveform object, so I will just do like this. I will create a slider object. And the output of this object goes from 0 to 127. I will just manually scale it 0, 127 between 0 and 1. So now the output goes between 0 and 1. And then I'm going to multiply this output by the length of the buffer. So we are going to have a number that goes between 0 and the actual length of the buffer in milliseconds. So let's get this number here, is this sender from within our buffer subpatcher, so audio file length in milliseconds. I could just use that as the maximum value, higher output value, yeah, we could actually do that. So let's go like this. And now the number that we get out of here, once we click on this bang and so get the duration of the buffer inside this input, then we will get a number that goes between 0 and the duration of the file. Cool. And then we can use this number as the selector for the audio file. So we could even visualize it here, attaching it at the selection input. So we have kind of a slider that goes around. Okay, that's not the intended behavior I wanted. So let's actually connect another cable. Let's sum this to 50, or then this will be the duration of our that we want for our grains, and this will be the end of the selection. So exactly, we are always selecting an amount of buffer, also visually in the waveform, that is corresponding at how much we are reading. Let's change from the inspector of the slider object this thing. My picture is on the way, it's very annoying actually. Yeah, let's change the indicator of the slider from indicator to indicator. So from indicator plus to indicator. So it's going to simply give us this kind of line that we can move around inside the buffer. Okay, cool. So now we got a way to kind of scrub visually using the waveform object. So now we get this number. This is going to be our initial starting point in milliseconds. So let's create a sender and call it maybe initial, or maybe just buffer start read milliseconds. Cool. I don't know if this sender name makes much sense for you, but you can choose the name that makes more sense to you. So I will just get it, go inside grain params, and we are going to sum these. So we're actually going to bypass these random object for the moment. Actually, we don't need the audio file length here. We are actually going to multiply this for the moment by 0. And then we're going to sum to this number the starting point. So this is going to be at 0, and this we're going to sum it to the starting point. So it's going to always start from the starting point, and then we have to read 50 from this starting point. So we're going to read the grains of duration 50 milliseconds starting from the point that we choose. So let's try this out. Let's make the output a bit louder, and then I will scrub and see what's going on. Sounds pretty cool. Let's go one time through the word buffer. Okay, pretty funny. So this is cool, but let's introduce a bit of randomization on the starting point. So we could introduce random numbers and say, okay, start maybe 50 milliseconds before this point or 50 later. So, and all these grains sum together, then it's going to create a more interesting effect. So let's create another sender here and call it like variation starting time, also in milliseconds. And cool, then let's get this sender, let's go inside our grains params, and we're simply going to multiply that by our random number that goes between 0 and 1. But if we just multiply it like this, then the numbers are only going forward because it's only producing positive numbers, so we are only reading some points after the starting point. So we should actually first scale 0 and 1 between -1 and 1. We could do it also in another way, but that's the fastest way. So let's just scale these from 0 to 1 between -1 and 1. So now we get also that the numbers could also be negative. Actually, we never want to go below 0 because below 0 there is no buffer time. So we could say we could put a maximum object and say 0. So it will take the maximum number between whatever comes in and 0. So let's just put it here. Cool, let's see how this sounds. So let me make this louder. Let's give it, for example, that it could read between 100 milliseconds before the starting point and 100 milliseconds after. And it sounds pretty interesting. Let's try with another audio file. Let's try with the harp riff. Let's try with the drums loops. That sounds pretty good. To make this number smaller, it's going to be to read a very small variation in the starting point. Sounds pretty cool. Let's try with another one. Is that you? Let's try with a bigger, for example, 200 milliseconds. Cool. So, okay, that's working. Let's now add the pitch of the grain. So we want maybe to play those grains all not at their original pitch, but actually with a different pitch for every grain. So in order to do that, we have to relate to each other the time that we took to play the single grain and the actual amount of time in the buffer that we are reading. So it's simply a matter of multiplying the pitch by the duration of the grain. So for example, if I got a pitch of 1 and I multiply this by 50, Then I'm going to send this number as the arrival point. So I'm reading 50 milliseconds of audio in 50 milliseconds. If I would multiply 2 by 50, then this would be 100. So if I want to play at double the pitch, then I would read 100 milliseconds of audio in the same amount of time as before, so it will sound as a double pitch. So that's a very easy way of determining the pitch. So we could do it like this. Let's create a multiplier, basically multiplying this number by that number. It actually doesn't matter which one we input. We should be able to always trigger these calculations. So I will create a trigger bang F in order to always trigger this calculation. Doesn't matter what happens. And then this is going to be our grain, so how much we read from the grain. So amount to read in millisecond, something like that. And we're going to copy that, and we're going to use that as our arrival point in milliseconds. So we're going to sum that to our initial starting point in millisecond. Cool. So let's say that I want to read the grain in 50 milliseconds, and this should be a double the pitch. So let's give it a try. Exactly. Cool. So now we are reading the pitches, the grains at double their pitch. As you can hear, it sounds pretty weird. Let's diminish the random interval. Sounds pretty funny. Cool. One thing that we could do is to also introduce random variations in the pitch, so that not all the grains sound with the same pitch, but some sound with a different pitch, some sound with another. So this will introduce even more variation in the sound of our synthesizers. So in order to do that, we have to change in how much time we read the single grains. We could also do it the other way around and change the amount to read in milliseconds, but it doesn't really matter. So let's actually do it by changing the amount of time that we take to read this amount of buffer. So let's copy this part with the random that goes between 0 and 1, and we'll actually encapsulate this and call it random 1, which means it goes between 0 and 1. I will just copy this sub patch, put it here, and what I will do is to multiply that by a number that we send to this multiplier, which will determine in percentage how much variations in the pitch we will want to have. So let's multiply these. Actually, first we need to scale this as well between -1 and 1, because we could also want the pitch to be less than the original pitch. Cool. So this we multiply by a number that goes between 0 and 1. So this will be the max variation in pitch. Connect this to the multiplier. And then we're going to multiply that by the max grain duration. So we are going to multiply this number, yeah, exactly, by the max duration in millisecond that we want to read this grain, which is this number here. And now this number, if we set some numbers here, so now this number could go between -50 and 50, right? Because it goes -1 to 1 multiplied by 1, then it goes between -1 and 1, and multiplied by 50 goes between -50 and 50. So if we want to still be in the range 0 to double our pitch, and then we simply have to sum that to our original grain duration. So let's actually remove this float number because it's not really useful. And so let's try here with 50, and let's create this sender for the amount of maximum variation of the pitch that we want to have. So let's hear how does it sound. So if we say 0, it means we don't want to have any variation in the pitch, so all the grains are playing with the same pitch. And then we can go up to 1, and at 1 they will sound either at double the pitch or at completely 0 pitch. So let's try how this sounds. And then it sounds pretty funny. Yeah, it sounds pretty cool. Let's try with another audio file, maybe the drums loop again. And this kind of watery sound then when we change the pitch so much. We can also probably go above 1, and then we are... when we go above 1, we are going outside of our original pitch range. We could also go below 0, which is not something that we want for the duration. So let's actually introduce also a maximum number and say, okay, never go below the duration of 2, for example. So it will always take the maximum number between 2 and whatever we input. Cool. We could also choose the variation. We could also choose our pitch using a key slider object. So the keyboard, basically. And then we could choose this pitch as the ratio between the notes. So for example, if we take this CF48 and then transform this to frequency, then we could get this frequency as our center frequency. So this would be when the grains play at their original pitch, and then divide basically everything by this frequency, which is 130.8 or something like that. And then we can use that as our pitch amount. So for example, here the grains will play at their original pitch. If I go 1 octave over, they will play a double pitch, and so on. So let me maybe use a live dial to change the variation in pitch. We can put this between 0 and 1 from somewhere here. Sadly, there is still my image. So mention unit style float, range 0 to 1. It should work exactly. So cool, so now we can change our pitch variation between 0, so no variation at all, it will just play at this pitch. So we can kind of play the audio file, and 1, which is going to completely mess up the variation of the pitch. Cool. Cool, let's try with another audio file. Let's take the prim loop. Let's reduce the pitch variation. Can use also maybe a float number here. It's pretty funny. I wanted to send also this as the max grain duration in milliseconds, so we can see effectively how much we are reading of the buffer also visually from here. So for example, something like that. Smaller. So this is our variation starting time. We can make it 100. I can change a bit the pitch. Want to reduce the number of grains, we can make this number a bit higher. So then they will sound like this. That's pretty funny. Again, have this kind of wall of sound effect. It's pretty cool. Cool. So one last thing could be to make this buffer play automatically. So kind of have these numbers simply moving around automatically. And we could actually simply do it with a line object, for example, very basically. Not even an audio line, just a normal line that outputs the numbers maybe every millisecond or something like this. And we could go between the beginning of the buffer and the end of the buffer in the total length of the buffer. So we could go between 0 and $1 in $1. So we will play the buffer at this original pitch. And then we could attach this to this slider. No, then we could attach this to the number down here, and then we will play the whole buffer and granularize it as we go. I would also like to attach this number to the slider here. So let's create another line and say that it goes between 0 and 127 in this amount of time. Cool. So let's connect this to this slider. Actually, we don't even need this one then, of course, silly me. So exactly, yeah, something like that. So let's click here on this bang and we should read the buffer at its own pace. So then we could just loop it like this. Then we could play a bit around. We could also play the buffer not at its original speed, but for example we could decide to divide the speed by 2, so this is another pitch shift again. No, actually I need to multiply this by 2 if I want to read that slower. Could read this very slow. And let's see how it sounds. Alright, so this was it. We could go on forever messing around with this granular synthesizer, adding parameters and stuff, but this is kind of the core of it, and I'm very confident that you can go on from here. So I hope this was useful, you liked the trip, and I had a lot of fun in creating this synthesizer and playing around with it. So if you liked those videos, I would really appreciate if you will subscribe to the channel, maybe put a like to this video. And if you're interested into Max and Jitter, then you can check my Patreon. There is a lot of interesting material there about Jitter mostly, so visual stuff in Max, but also a lot of other things. So thank you very much for following me in this madness, and see you all in the next videos. So have fun, ciao.